it decided to speak to me this time when I hit record. Never done that before. So why not? Also just the first two parts on this one were pretty easy, right? Like that wasn't just me doing something wrong.
I think the first part was pretty straightforward. It took me a little while because I was trying to understand his class example thing.
Right.
But once I understood it, then it was pretty quick to go through.
And when you guys are talking about part 1 and part 2, are you talking about the tasks in part 1?
I was just kind of talking about part 1 and part 2 in general.
Yeah. Okay. Yeah. I mean, it was pretty straightforward in my opinion as well. It's, you go through his code and then apply it to the IMDb or Amazon, and then in what's that notebook called? Yeah. Anyway, it was pretty straightforward.
In the collab notebook. Yeah.
Yeah.
Yep. I'm still working on the second part. I'm partway through it, but I haven't quite got it wrapped up yet. So.
Yeah. Same. Pull up my.
Gray, I know yesterday you had mentioned that you were working on the first task of part 2 on how you determine the number of parameters.
Yeah.
That was a quiz question too, wasn't it?
Yeah, and I had no idea how to do it on the quiz either. I kind of just took the loss on that one.
Okay. I thought
on the quiz?
Yeah.
I
got the points on the quiz, so I think I know how to do it.
Yeah, I know how to do it too. I just need to refresh my memory on what the question was.
Yeah.
Okay.
I got logged out of all of
yeah,
so I'm trying to get my code back in.
Or I think I can just pull up on my phone what it's pretty straightforward. Dang it.
Yeah, just 1 sec. I honestly have no idea how to actually do that.
So I'm looking at the quiz question right now.
Mm-hmm.
And the math that I had done was for your first layer, it's basically the input times sorry, 1 second. Oh yeah. Kind of like the input to a layer times the output to the layer plus any bias. So the first is then the connections between the input and the hidden layer. So there's 3, your size going in is 3, and the hidden layer has 100, the shape of 100. So then that was 300 parameters.
Gotcha. Right. You're talking about the quiz still.
Yes, but I think it's the same thing in the homework, isn't it?
Right.
Just different numbers.
Yeah, it'll be the same thing. I really can't find my
It's just another dimension, so I think it's just another multiplication.
Yeah. Where's the quiz? 1 second. I'm trying to find this thing.
Okay. So the one here on the homework has the shape of 20/100, so it would be 20 times 100, which gives you the 2000, and then it's got a bias of 700 from somewhere. Am I understanding that right?
I am trying to figure that one out.
I just don't see where that 700 would be coming from.
I'm opening up that entire collab notebook, so like the snippet that he showed there is
Yeah.
not enough.
Gotcha.
Okay, I got it open finally. Okay. So yeah, so the example in the quiz, right? So yeah, first layer, second layer, third layer, and therefore the total number of parameters. Okay. So you have the first layer, you have, I believe it was the output shape. Sorry, it's the in. Give me a second. So I got it right. So it was 100 times 2 plus 1 equals 300 was for the first layer. So the 100.
The 100 times 2, that's the output shape times the input shape. That makes sense.
And then the input channel is the plus 1.
Input channel. Remind me where exactly it says what the input channel is?
Are you looking at the quiz right now, or the
Yeah.
homework?
I'm looking at the quiz.
The input channel comes from the input shape, right?
Okay. Oh, is that just because it's only got the one value in there?
Like, is it, since it's one dimensional, is that what you're saying?
Yeah. Because you said it was the 100 times 2, and then did you say plus 1?
Yeah, 100 times 2 plus 1. And then I mean, it's the same for
That's
every.
the third layer, right?
That's
Yeah,
the first layer.
That's the. Wait.
No.
100 times 2 plus 1, that only gives you 201. There's 300 parameters.
No, so it's 100 times 2 plus 1 in parentheses.
Oh, I see what you're saying.
Yeah, sorry. But yeah, so okay, never mind. I made a note about it. So it's the output channel times the input channel plus 1. But again, I don't remember what the plus 1 is.
Well,
Do you know, how about for the homework? If we look at that one.
Let me pull that up. Okay. So which one am I looking at? So part 2, I assume, and then it.
Yeah, part 2 of the embedding layer, they have 2,700 parameters, which I don't quite understand how they're calculating that. Like, I can see how they'd get to 2,000. I just don't know where the other 700 is coming from.
Right.
And if we did the plus 1, we'd end up at 3,000, which is 300 over where we're meant to be.
Right.
Give me 1 second. I'm trying to grab a piece of paper, do some hand calculations for a second.
Yeah.
So when I was doing some research on how to calculate this, I got the formula that it was your basically your number of inputs plus your number of outputs times the number of hidden layers plus hidden layers plus your output, which seemed to work for the quiz, but I'm not following it for the homework.
Yeah.
Number of,
Let me.
what was that formula again? Number of inputs times number of outputs. What?
Inputs times output. Oh, sorry. Inputs plus outputs times hidden layers, and that value plus the number of hidden layers plus the number of outputs. What I'm wondering now is how does that work with multi-dimensional outputs?
So hold on, I actually found an article that I think is specific to LSTM.
So can you go through that just one more time? I'm trying to type and I kind of stuck at it.
No worries. Give me one quick second, actually.
Yeah. Yeah, take your time.
Whatever it is, it's not at all coming up to what the little table has in the homework.
Of course not. So maybe I'll just ignore that. That one's for, let's guess that.
I'm almost positive I found how to do it. I'm just not sure what 4 is here. Let me give it a crack real quick. Let me see.
Mm-hmm.
Okay.
So
I found a formula that I'm not entirely sure I believe works. So let me.
yeah, we might be on the same thing. Well, what are you on? Are you on a Medium article?
Yeah.
Yeah.
That's the one I was quoting to you earlier.
Oh, fun.
Okay. Cool.
So let's see. It is the input size times the layer.
Okay.
Okay, now let me just run through this real quick, see if this actually works out. So
Okay, I figured out layer 2.
Okay.
That Medium article has down near the bottom for the LSTM parameter number, like the 4 times x plus h times h plus h equation, that works for parameter 2 or for layer 2.
So I think, so what did you do? 4 times?
So 4 times open parenthesis 100 plus 256 close parenthesis times 256 plus 256 close parentheses.
Okay, the second parentheses is where it threw me.
Yep. Basically, it's like it's like 100 plus 256, multiply that by 256, add another 256, and multiply all of that by 4.
100 plus 256 times 256 plus 256 times 4.
Yes, in that order.
Okay.
Like do the math in that order. It's written in a different order, but order of operations.
Yeah.
So let's see. I'm going to give up on trying to do mental math. That number's getting far too large, far too quickly.
All right. Yeah, I got it. Okay. I'm gonna, I guess, try it later the way it's. What Medium article are you on? Is it calculating number of parameters in LSTM unit layer?
My article is called LSTM, Understanding the Number of Parameters.
Yeah, that's the one I'm on too.
Okay. All right, I'm on a different one. I'll find yours. This one calculates a little bit different, but if you can get there, what does it matter, I guess?
Well, and the first layer had a different formula that it followed?
So yeah, because a single dense layer is different.
Okay.
What my confusion right now is, oh, that's why the first one's an embedded. The quiz was all dense.
Dense.
Gotcha.
And that's why my equation works for dense. We just did the equation for the LSTM.
Right.
Need an equation for how to calculate number of parameters in an embedded layer.
And the formula for a dense layer is the input size plus the output size times the hidden size plus the hidden size plus the output size.
Yep.
Okay. Cool. If I have the formula, I can do that then. And my thing failed again. That's fun.
I looked through all of his like slides and couldn't find any references to these calculations.
Just a second. I think I may have left my own. I did indeed leave the oven. Turned off now. be honest, I'm really starting to regret what I decided to do for a final.
What are you doing?
I'm trying to train a neural network that can colorize black and white images. But in order to do that, I need a data set that has the labels as images. And I can't figure out how to save that because apparently Pickle has to be one-dimensional.
Huh. Did you email him about that? I mean, he
Not yet.
suggested to me that, so I have a bunch of UAV data that's 4-channel, and he suggested that to me. Even I didn't wind up doing it. I mean, I'm just using a subset of the data I have right now to build a prototype, and he says he's okay with that. So
Okay.
I just made a 40 array out of that essentially. But anyway, the point of that is he mentioned that to me on 4-channel data. So, I mean, maybe he has some type of intuition of how it works.
So what did he mention to you? You kind of cut out there in the middle.
Oh, sorry about that. So for my final, I have a bunch of 4-channel data. And essentially, we can't treat it like a traditional image because a lot of the Python packages that use, you know, image data generator or data generator use PIL in the background, and they can only load in 3-channel images. So we thought as a workaround, we could use Pickle. I wound up just loading all the imagery into a 40 NumPy array and doing it that way. But he mentioned Pickle, knowing my problem, so I feel like he would have some idea how to do it.
Okay, I can shoot him.
So I would just ask him.
Yeah, because my images are actually 4-channel images as well.
Okay, yeah.
Just not wanting to work.
I figured it out.
The formula for embedding. Okay, so yeah, we kind of got distracted.
Nope, you're good. Actually, you can keep talking. I have to look up one more thing to make sure I understand what's happening.
Okay. But I guess, yeah, so do you have to Pickle the data, Gray, or
I just want some way that I can save the data so I don't have to rebuild the entire data set every time, because it takes a few hours for it to do that.
Yeah, a lot of these issues, yeah, as soon as you start getting out of a traditional image bands, like there's only so many packages. I know GDAL's one, because a lot of this stuff's from remote sensing. So have you heard of the GDAL package? Or
I think I heard about it.
People call it Rasterio, other people call it but there's another one called Rasterio or Rasterio.
I think I heard about it a couple years ago.
I can send you a few lines after this that yeah, trying to think.
So for the embedding layer, I haven't found anything that says this is the right equation, but it's the input dimensions times the output dimensions is what the value says in the table. So if you look at the code where it says, like, you know, the model add embedding, there's 3 values. There's n vocab, embedding dim, and your input length. N vocab, I believe, is your input size, and n vocab, if you look up a ways in the code, is a size 27, and the embedding dimensions is 100.
Okay,
which is your output. So your input times your output is 27 times 100, which is 2700.
Gotcha. Yeah, that would explain it, because I'm only looking at the little bit that's on the assignment write-up.
And that
Yeah.
matches what I did for the quiz, which is that your first layer is the simple layer. It's just your input times your output.
Okay, gotcha.
From there, it gets more complicated.
Okay.
So I think so. And then I think if I finish the math all the way out, the last one,
Okay, I've just learned that I might just be an idiot. Wasn't having issues when it, sorry, completely unrelated. It wasn't having issues when it was trying to pickle the stuff. It was having issues trying to build the data set. Oh, right. I forgot that I have the free version. I thought we'd been going for this long. Yeah, we've got about 10 minutes left in this recording. We can always do another one right after. But at least as far as the rest of the homework goes, I mean, everything's fairly straightforward.
Yeah, I felt that way
Yep.
too. I mean, these compared to the
I
last.
just like doing that's the intense part.
Yeah. I feel like I've got mine under wraps though so far.
Yeah.
Must be nice.
My metrics are pretty crappy at this point, but
What do yours look like?
for my research paper, I'm
Yeah.
at like, where to go? I mean, because I just did some basic, like I did a linear model, a lasso, and a ridge model,
Mhm.
but with like very little messing around.
Mhm.
And I'm getting like a mean squared error of like 0.6.
Okay.
And if I then convert if I look at it from a classification lens, so basically instead of trying to figure out what percentage change is happening, I just say, okay, wait, am I at least estimating if it's going positive or negative? I'm getting like 40%, 48% accuracy on at least predicting the right direction of movement for my values. So, but I know I need to do some analysis on weighting each of my parameters, each of my feature sets, because I've built my own data set, and it's the each feature is definitely not the same weight. So
Yeah.
I expected my results to be poor at this point, but yeah.
Yeah, I'm just hoping by tonight I can actually start training something. I built a prototype because I have MATLAB on my computer downstairs. And it's just a lot faster to prototype, and that's training right now. But yeah, I didn't know what to expect on mine. So essentially what I'm doing, I'm trying to predict yield just based off of the imagery data. So I had about 16 UAV images over this area of Columbia, Missouri, that the University of Missouri Columbia owns, called the Bradford Research Center.
Okay.
And 4 different soybean genotypes. And then I have the corresponding yield to each plot. So it's plot level yield prediction, just completely data driven. And I
Yeah.
didn't know what to expect just because this isn't traditionally done this way. You feed in a lot of other, either like NDVI values, so like the vegetation indices and stuff like that, or weather data along with it. So
Okay.
I'm kind of interested in seeing how it's going to do.
Yeah, that is interesting.
Yeah. So
Yeah, I'm doing financial analysis, kind of like financial based analysis. So I'm trying to determine what factors have the most effect on this average savings rates of Americans,
oh, cool.
and
Yeah.
then use that data to try to predict changes in which of these features would increase savings rates.
Oh,
So
cool.
I have like the savings rates for the last like 80 years from the Federal Reserve, the average income, unemployment rate, inflation, tax rate, and then I'm looking at like NASDAQ and S&P 500.
Oh, cool.
So basically, like it's pretty generalized. It's like looking at stocks, I just taking the two like big ones, and for like average income, it's just like one average value. For tax rate, it's the across all spectrums, what is the average like final out-of-pocket tax rate for Americans? So
do you feel like if you use this for like a jumping off point for future research, you'd try to factor in more socioeconomic factors?
Yep. I would start breaking this down into socioeconomic, geographical, all sorts of people groups, basically start taking those into account. Right now, I'm just trying to say the average American.
Sure.
Yeah.
So I know
also,
there's a class offered, I think it's just called spatial statistics, and or maybe it's demography, where I took the first in the series. I think the second one was called spatial statistics, but we used a lot of these data sets from the Federal Reserve for stuff like this. So if you have an interest, research wise, it might be worth taking. I know it's on the curriculum for the AI masters, but I don't know if it's
if you remember, could you send me what the class is?
Yep.
Yeah.
Yep. Cool.
Yep. I would be of interest, and I feel like I could make a case to bring it into my CS one,
definitely.
even though I'm the AI. Because the financial markets is something I'm interested in. I'm trying to get them to let me do a independent research study this next semester on blockchain development.
Yeah, you're telling me that. Yeah, that'll be cool.
I just haven't gotten a professor to support me on it yet.
Yeah.
All right, with our couple minutes left.
Yeah, I feel good about the homework for the most part.
Yep, I think talking through that, the math was my biggest open question at that point, was just trying to sort through all those equations. Just so you know, so for the embedding and for the dense layers, it's input times output plus any bias. So the input didn't have bias, but the output does. So the output was basically your input of 256 times your output of 27, and that dense, the first parameter of that dense is y shape 1, which is 27. So 27 times 256 plus 27 is a 6939.
So size of the input plus size of the output times the bias?
No, input times output plus the bias.
Gotcha, I got my symbols on
and that was, yep. And that was the same for the homework, basically, that I did.
Okay, cool.
Or not the homework, the quiz was saying that. Yeah.
Sorry, you said 27 times 256 times what for
the last layer?
Yeah, never mind. I got you. Plus 27. Okay. Yeah.
Yep.
Yep.
So.
Okay.
And then the last one's easy. You add them all together.
Well, slow down. Your tree looks good. Your Christmas
tree. Yep.
Yeah, I mean, I'm good on my end if you
Yep.
guys are.
I am as
Yeah.
well. I gotta finish documenting that part too, and then I can submit.
Cool.
I just need to figure out what the hell's going on with Numpy and all that fun shit.
Cool.
Right. If you want
Okay.
to send us a link and the password to the recording whenever it's
Yeah.
done
once-
uploading to the cloud.
we'll do that.
Awesome.
Cool.
Thank you.
All right, guys. I'll see you tomorrow.
Sounds good. See you.
Bye.